Original recording of this course, the keyword volatile was actually new of that version of Java. So we didn't record it originally with that concept in mind. So one of the things we'll do to make this thread safe is we'll go up to line 5 here and say private static volatile. And this will help us ensure that that instance will remain a singleton through any of the changes inside of the JVM. The other thing we're going to do is to ensure that nobody uses reflection on our code. So we're going to go to this private singleton that we've made and say if instance does not equal null, then we are going to throw a new runtime exception. And inside of here, we'll just say use getInstance method to create. And we'll close this. Now that will create our instance to where it's volatile and can't be reinstantiated through different things going on in the JVM. This will also protect us from having a reflection class go ahead and create an instance of this. Now the next thing we're going to do is we're going to come down to our getInstance method. Now we could do this a couple of ways. We're going to implement a double check locking mechanism and a synchronized check. Some people would originally on line 13 just make this whole method synchronized, and the problem with doing that is it's a performance hit. If we make this whole method synchronized every time we ask for an instance of it, we're going to actually synchronize that class and slow it completely down. Rather than doing that, let's go ahead and look and see if our instance is equal to null, and if it is, we're going to synchronize inside of here. So we'll say synchronized. And we're going to do it on the singleton, the DB singleton class. And then we're actually going to check for null one more time. And the idea behind this is that it's only going to actually happen if we're creating this one time. So it's a little bit of extra code, but it should only run if we're actually creating this for the very first time. So we'll do the exact same code again, and we'll say if instance is equal to null, then create our instance of our DB singleton. From there, we'll return back out our instance. So we added our volatile to our instance. We protected this from being instantiated through reflection. Rather than synchronize on the whole method, we check to see if the instance is equal to null. Then we synchronized on it. And the reason for doing this is it may be null, but if the two threads are trying to go at it, once we've synchronized and checked for null again, if another class has a lock on that, it will then block our code and create the instance and return that synchronized lock to where our code would now go back in and say, if this instance is null, it go, oh, nope, I'm already created, and return back out of this. So you can see how that double check with volatile instance inside of there is handling that functionality inside of our class. Now let's double check this by going back to our demo and running it again. And you'll see that it works correctly. You're not going to notice a real performance hit inside of our application now because we're only doing this with 2 instances across our main method. But it does add a little bit of overhead with that synchronization inside of there, but at the safety of our application not having multiple threads accessing this and our singleton really not truthfully being a singleton. We are now lazily loaded, thread safe, and we're using the latest version of volatile inside the JVM to make this a fully thread safe instance of a singleton.